aware of their responsibility towards the conservation of our natural resources and protection of the environment. If we take this responsibility, surely it will bring about a pragmatic shift in our approach from degeneration to regeneration of the environment by building sustainably. Thankfully, we are now living in a high-tech era where we have access to energy softwares like Ecotech, eQuest, Design Build, etc., with which it has become quite possible to do energy simulation to know the amount of energy usage in buildings beforehand. But the only thing which is required at our end is to use the energy in the most judicious way so as not to overburden our Mother Earth. Lastly, I would say, in the words of ex-president of US, Jimmy Carter, every act of energy conservation is more than just common sense. Rather, it is an act of patriotism. Well, today we have 3 thoughtful presentations to continue the dialogue. The first presentation is by architect Surinder Baga of Sakar Foundation on energy efficient architecture. This presentation will take through his journey into design energy efficient buildings. The second presentation will be on PAT, Perform, Act and Trade in Industries by Engineer Balkar Singh, retired Joint Director, PEDA. And the last presentation of the evening will be on a very crucial aspect of the energy reduction, that is the new design options to reduce building HVAC energy by Engineer A.C. Verma, who is an HVAC consultant. Dear friends, hope we all take full advantage of the knowledge being disseminated by our knowledgeable experts. Thank you so much.
Thank you so much, ma'am, for introducing the theme of the webinar to all of us and highlighting the need of energy efficiency and actually making us realize how stakeholders play such an important role and actually mentioning it as a patriotism towards our planet Earth and our nation for the same. Now, I would like to invite our star speaker, Engineer Akshay Gupta, who is the Director of Passive Design Consultants and an ECBC Master Trainer. He is well known for his work as a green building consultant in the UK and the India. He will be talking about the energy efficiency in the buildings. Over to you, sir.
Hi, Mansi. Thank you for the lovely introduction. Am I audible?
Yes, sir, you're audible, but your video feed is not on.
Yes, so I am just sharing my screen because I think that is more important.
Okay, sir.
So, is my screen visible now to everyone?
Yes, sir.
Great. So I again thank you for having me here on this webinar. I thank BE, PEDA, Sakar Foundations, everyone for inviting me. I think my topic was that's been given to me, or I've been requested to speak on energy efficiency in building design. So I'll take you through, I thought the best way would be to show you through some of our project examples, what we do and what we have done in this area. And I'll take you through this one project, one case study to show what would be a logical approach for energy efficient building design. So this particular project, it's a hospital building. So it's a 24/7 use. It's used for all 365 days in a year, 24 hours, all 7 days a week. The project is located in North India with a composite climate, very similar to what we have in Punjab. The project has a total built-up area of around 50,000 square meter and building height of approximately G+9 with 2 basements. Just for the context, the project also aimed to achieve IGBC platinum rating, apart from meeting ECBC Energy Conservation Building Code as a codal requirement as well. From the image that I show you here, you can see how the architect initially designed the building. It's a building you can see which has almost 100% windows on the facade. So everything is cladded with glass, everything is glass primarily, which is shown here. So this is the kind of design which was given to us by the architect, and we being the ECBC and green building consultant in the project, uh, rethought the entire project from all perspectives of sustainability as well as energy efficiency, and guided not just the client but the architect how it can be remodeled, or with the same design but some tweaking in the design, how we can really optimize on the performance of the project overall without really increasing any project cost. So to begin with, I would like to tell that in order to achieve high performance for the building, in order to achieve energy efficiency for the building, we tend to use a lot of building simulation softwares. Like Aradhana ma'am just said, there are so many tools available in the in our industry now, which can predict how a building would perform on its building envelope level, at the air conditioning level, MEP services level, and others as well. So there are softwares for calculating how the sun will move around the building, how much radiation the project will get on different facades, roof, how the energy consumption pattern would be for the building, how the wind will move around the site, and so on. So we took maximum use of such softwares to predict the building's overall performance in different areas. And I'll take you through that journey of how the project, kind of performed with the initial design, and how we, developed kind of a framework or guidelines for the architect to further lead it through to make it energy efficient. So we started with the solar insolation analysis in the project, and on your left, what you see is the building plan from the top, and a red line basically dividing phase 1 and phase 2 of that project. And on your right, you basically see for both phase 1 and phase 2, the hospital buildings, solar radiation analysis, how on different facades, what kind of radiation we are getting. And obviously on the north facade, we see a dark blue color, which means a very minimal amount of radiation actually reaches that surface. Whereas for the south, east, and west, the radiation levels are relatively much higher, almost to an extent of 4 to 5 times of what we achieve in the north facade. So how do we use it? We further also did insolation analysis on a pedestrian level for open areas. That how in the open areas around the hospital building, how much solar radiation we will achieve. And the idea for it was not to look at building in isolation, but rather think about areas around our building as well, because when we design a building is not just designed for occupants within the building, but even for a building like hospital, where people use even the exterior areas to a lot greater depth, because those outdoor areas act as buffer spaces, those act as spill out spaces, those act as cushion areas for the people who are coming to the hospital. So we wanted to design even or address even the outdoor areas, the surroundings, the microclimate of the project. So we started analyzing also not just the building envelope or the facades, but also the areas around the building, what kind of radiation they are getting, and analyzing the potential for urban heat island effect. Being a hospital project, the architect tend to provide a lot of paving all around the building, from the vehicular movement point of view, from the accessibility point of view, from fire tender point of view, and all. And we rethought, can this be relooked or can this be redesigned in a more sensible way? And doing this analysis, we identified pockets which received relatively more radiation. So the brighter colors, yellow, red, orange, that you see are the zones which receive a relatively much higher level of radiation. However, the darker colors, the blue, basically what we see is the building footprint. And between blue to yellow, the gradients are shown, which are relatively milder radiation zones. We identified those areas which are very bright to have more potential of urban heat island effect, where the paved areas absorb more solar energy and re-radiate back, making the microclimate warmer. So the microclimate, the area or the air around in that area tend to be a few degrees higher during summer, and make it even hotter in a composite climates where typically during peak summer, the outdoor temperature goes almost up to 44, 45 degrees Celsius. So the first thing we proposed to the client was, to the architect, was there was a big canopy which was proposed in the project, which was on the northern facade. And we proposed that instead of having a glass clear canopy, we should be using an opaque canopy or a dark color glass canopy, which can shade all the areas below it, so that all the people who come, and the entrance zones are quite busy generally in hospitals. A lot of people tend to stand there or sit there or wait there for as a drop-off point as well. So we propose to have that canopy in dark so that we can get shade. And you can see in the animation below how during the day the sun is moving around it and the shadow pattern is generated by that canopy. So we try to provide a passive shading just by the shade itself, which was provided earlier. Further, on the northern zone, which was predominantly designed to be a fully hard paved area, we proposed to the client and the architect that the zone can be developed as an urban forest plaza, so that it is not only accessible by the fire tender, but is well shaded by greenery, by trees, and the trees not like palm trees, which do not provide us any shade, but trees which are native, which are local to our climate, like neem, trees like gulmohar tree. These are the trees which provide you ample shading. They provide you ample coolness around and below. So, created a new vision for the front of the building, that the space is very much pedestrian oriented, and we must provide shading for the pedestrians, for the outdoor users. And this will not only benefit the users outside, but also alter the microclimate around the site, which will further help us reduce energy consumption of the building, because the environment around the building itself is relatively now calmer or less hot. The project had a central courtyard, which was actually at a height. It was not, the courtyard did not have its base on the ground floor, but rather on the 7th floor of the building. So we propose that the courtyard can really act as a spill out space for the hospital users, and hence we should try to. And the courtyard, as you can see, was on the southern facade, southern side of the project. So it will receive a lot of direct radiation throughout the day. So we propose that the courtyard should be shaded with space frame having shading devices, and the shading planes could also be solar panels. So they will not only reduce the radiation reaching the courtyard, but also generate energy from it. So it works as it serves dual purpose in the project. The surface of the courtyard at the bottom, at the terrace level, we proposed to convert it into a terrace garden, so that the spill outs, the courtyard act as a spill out space. People like to come out, enjoy greenery. And we know hospital zones could be very stressful for the occupants, for the patients and their attendants. And this kind of space could be a big relief for them. So it's not only for the energy efficiency, but also for the psychological benefit of the building users that we propose this kind of a strategy. And as we know that terrace garden tend to reduce the heat gain from the terrace to the floor below. as well as they improve the microclimate again, bringing down the ambient air temperature and reducing the overall air conditioning load in the building. Additionally, the zones of the project which were identified for creating open surface parking lots, we proposed to the client that all those areas should either be designed with soft paving, having grass pavers, or should be planted with a lot of trees for shading in the parking, so that we can minimize urban heat island effect. And the parking lots can also act as spillover spaces, and they are not merely hot concrete large paved zones. We analyzed how the project is located and how the wind will flow around that project. So we could see the north sign here, and for the project, the predominant wind direction is northwest. So we identified that the frontage of the building, the front facade of the project, which is the northern facade, will actually, and that area in the front, which is majorly meant for pedestrian activities, will receive good amount of ventilation. So in order to ensure that and validate that, we did wind CFD analysis, which is computational fluid dynamics, where we can predict how the wind will actually move around the site on different levels. And we identified that actually that entire front area, which is meant for a lot of pedestrian activities, will be very well ventilated, will not really suffer much in terms of wind movement. However, one might need to take note that this air is really hot. This is a predominant wind direction during the summers. So the air would be as hot as 44, 45 degrees Celsius. And at that temperature, the air flow will not be very pleasant for the pedestrians. So we need to alter the temperature of this air in order to make it comfortable for the people and also improve our microclimate. To do that, we studied a physiological equivalent temperature. We called it PET analysis, which takes into account vegetation, humidity, wind velocity, activities of people, the kind of clothes people wear, solar radiation, etc. So these are all different factors which we study, and it helps us predict for open areas how a pedestrian would feel, what would be the feel like temperature in outdoor zones. And for the zone, we identified that with the current design, with a lot of paving, with negligible amount of initial shading, which was designed by the architect, even when the outdoor temperature is 43, 44 degrees Celsius, people standing out there will actually feel around 62, 63 degrees Celsius. And that is because it's a feel like temperature. The paved areas below him, below the person, will also radiate back heat to him. From the top also, there's a scorching sun, which is radiating its infrared rays on people or radiation. And combined with the hot air, which is blowing toward to that person in that zone, it will actually make him or her feel at least 20 degrees higher than what would be the ambient air temperature during peak summer afternoons. To mitigate that, we propose to the client very strategically where we should introduce water features like water mystifiers or water fountains. These are the very basic strategies which probably will not take much of space on ground. The systems can be buried under the ground. And during the times of emergency, when the fire tender needs to move, they can still move over these areas. And having water misters or water fountains will actually give it a lot of surface area for water droplets to get evaporated, to use the evaporative cooling strategy for the hot wind. And we can help to bring down the hot air temperature and improve the microclimate. We analyzed with all the strategies we proposed in the zone, having trees for shading combined with water mystifiers and fountains. Together, both these strategies would actually help reduce our ambient air feel like temperature by almost 30 degrees. So instead of feeling 62 or 63 degrees, a person will actually feel 32 degrees because the air is now more moist, lesser in temperature, is colder, and the person is also well shaded from the scorching sun. So that's a huge difference, huge impact on starting with improving the areas around our site. So before addressing the building itself, we addressed how the areas around the building also needs to be modified or needs to be developed and approach for the external development so that the building load itself is reduced because the microclimate is improved. At the same time, improving the occupants and the pedestrians' comfort and experience of using those areas. Moving ahead, we started analyzing the renewable energy potential for the project. We analyzed how much radiation levels we were getting on different facades and roof. We proposed to the client that even if they introduce solar PV panels on the roof, they could, in fact, in this project, install almost 600 kilowatt of solar PV system, which would cost them approximately 2.4 crores. But the annual energy generation from that plant, solar plant, would be approximately generating 850 megawatt hours per year, which is equivalent to almost 85 lakh rupees. And that means that the client will actually save 85 lakh rupees annually. Hence, the cost of putting up the solar panel will be offsetted or recovered within 3 years. And such systems like solar PV have a lifespan of typically 25 years. So for the remaining 22 years, the client will really enjoy the benefit of free energy. This energy that would be generated only from the roof would be equivalent to meeting almost 10% of its total interior lighting energy consumption. We also used a whole building energy simulation approach, which is one part of compliance methods in energy conservation building code in Punjab and in India. And we use the energy model to predict and optimize on the building design. I told you what kind of design we received from the client. The project basically had 100% glass overall throughout the building on all the 4 directions. So we started with the very basics of minimizing or optimizing the window to wall ratio, which is the amount of windows we have. So instead of having structural glazing on all 4 facades of the building, we proposed to the client and the architect that we must reduce our window to wall ratio. And as per the ECBC recommended value, the WWR or window to wall ratio should be below 40%. For the project, we analyzed that it should actually be around 32%. And at 32%, the project could save almost 40 kilowatt hours per square meter of operational energy annually. And not only this move will save the operational cost in the project, but it will also reduce our chiller cost or chiller size by almost 180 tons. So reducing the chiller tonnage by 180 tons would mean that the capital cost of the project will also reduce. The electrical loads associated with those 180 TR will also reduce. And this particular move will actually save a lot of money even in putting up that glass, because putting up structural glazing is expensive. So reducing it from almost 90 or 80% to 32% or 35% will bring down the capital cost of the project significantly. So when people say that making energy efficient buildings or making ECBC compliant buildings is expensive, I always debate that. In my opinion, with a logical approach, the project would always have a reduced capital cost by moving with the systems and the designs recommended in ECBC and moving with the energy efficient building design. We actually build the building with lesser money and also save operational energy in the building in the future. We checked with different glazing options of the project as well. So instead of having clear glazing, we tested the project with having high performance double glass. And with that, we checked that additionally, we would be able to save around 43 units of electricity per square meter per year, which also means that we will also reduce our air conditioning load by almost 200 tons, again reducing our capital cost or the cost required for building the project. By changing the glass type from single to double, many people think that changing single to double glass have a lot of impact. Well, not for this building. We analyzed that saving was very minimal, only 1 units of electricity per square meter, and only 20 tons of cooling load was reduced by using DGU, by double glaze, by double glass. Additionally, we also checked what will be the benefit of insulating our walls, and again realize that because it has very minimal wall area, only 1 unit of electricity per square meter would be saved, or approximately 20 ton of chiller cost. So overall, what we did in the project was we started with the conventional building design, meaning the same design but with conventional building parameters, like a typical 9-inch brickwork for the exterior walls, single clear glass for the windows, and so on and so forth, and uninsulated roof, etc., etc. And by using all energy efficient systems in the building, like making good use of the daylight by putting daylight sensors in the building in areas where we achieve ample daylight, by using insulated roof, high reflective roof for reflecting back the radiation from the roof, AAC block work for reducing heat gain in the envelope, by using glass which has reduced SHGC of 25% and U value of only 0.5, by using exterior shades, and by optimizing our window to wall ratio, using LED lights in the interiors, and using energy efficient chillers and MEP systems or air conditioning systems, we could actually reduce down the energy consumption of the building from 436 kilowatt hour per square meter annually, which is the EPI for the project. From 436, we can bring it down to almost 290, which means the project would actually save almost 7.3 crores or 146 kilowatt hour per square meter, which translates for a 50,000 square meter building to 7.3 crores annually. So this is not only energy savings, this is actually cost savings also for the project, for the building. Imagine if we do this kind of value engineering for a project, if we optimize our building designs, if we make our building energy efficient, how much we can actually save at a entire Punjab state level or at a country level. The kind of carbon emissions that will be reduced will be enormous. And while doing all this, please mind that we not only save the operational cost of the building for 7.3 crores annually, we also reduce the capital cost of the building by almost 4 crores, because overall we were able to reduce our air conditioning load by almost 650 tons in the project, which was of a 50,000 square meter built up area. So with that, I think I've already taken a lot of time. I thank you all. And I would request my audience to ask any queries, any question that you may have. Thank you.
So we would request you to kindly show us your face so that we know who's behind our attendees will actually know who's behind the voice.
Absolutely.
Thank you so much, Akshay sir, for sharing the design strategies with an exemplary case study, I would say. Any building that is built stands for, I think so, more than half a century on the ground. and its energy pattern impacts not just the indoor area, but also the outdoor system as well.
Absolutely.
Being the stakeholders of the industry, it becomes our responsibility to not just think about the microclimate of the building, but also the macroclimate. And having such advanced strategies that you showed, like solar insolation analysis, wind flow analysis, CFD analysis, and PET analysis, basic design interventions, like just like by adding a canopy, changing the type of trees that we are using, changing the type of pavements that we are using, we can just not make the building more energy efficient, but I think more livable as well. Thanks for busting the myth of energy efficiency buildings being so expensive and the payback period being too high. Thank you for sharing those factual details with us also, sir. Now, moving on to our next speaker, Engineer Balkar Singh, who will be talking about PAT, that is Perform, Achieve and Trade in Energy Efficiency. He is the former Joint Director of PEDA. He is the recipient of prestigious Punjab government Praman Patra for his exemplary services in the field of science and technology. He has more than 32 years of work experience in the field of renewable energy, energy efficiency, construction technology and management, green buildings, energy audits, etc. Over to you, sir. Balkar, sir, your mic is on mute.
Thank you, Mansi.
Yes, sir.
First of all, I congratulate PEDA, B and Sakar Foundation for celebration of Energy Conservation Week. And today, my topic is Perform, Achieve and Trade, this PAT scheme which, of Bureau of Energy Efficiency. So when we start this, hello, am I audible?
Yes, sir, you are audible.
Okay. So first you can see that how the climate change is creating global warming, temperature change in last 50 years, and the consequences of that our Mother Earth is burning with the heat. So you can see here on the left side, there are industry, there is a thermal power station which is releasing carbon dioxide emission. And then on the right side upper, the vehicles are moving, and the lane of vehicles which is also releasing the carbon dioxide emission. And you can also see on the bottom, there are air conditioning units, and they are also releasing this GHG emission. With that, our earth is burning, and we have to reduce our temperature rise. So with the temperature rise, there are ill effects, and you can see that on the upper regions, glaciers are melting, and they are creating a rise in sea water level of the sea. And there are floods in the coastal area. You can see that the low-lying area in the coastal is flooding. And on the other side, there are drought and there are intensive heat where the peoples are experiencing diseases as well as they are hard to work. So this is the position. You can see that the GHG emission scenario of global GHG emission scenario, where we have the targets have been fixed for reduce this GHG emission from 2010 level to 2035, and energy efficiency has been taken as the first one, and renewable energy is the second one, and energy efficiency we have taken as a 50% reduction through the energy efficiency. In Indian GHG emission scenario, in India we have taken it more in energy efficiency, that is 51%, and renewable, we have almost double the target up to 32%. So enabling the framework of this, we have Energy Conservation Act, which has been enacted in 2001. And under that, the designated consumers are required to comply with the specific energy consumption norms. And second is National Action Plan on Climate Change. We have 8 national action plans, and one of them is National Mission for Enhanced Energy Efficiency. And third one is the nationally determined contribution, where we have to reduce from 33 to 35% from 2005 to 2030. So intended in nationally determined contributions, now we have to put forward and further propagate a healthy and sustainable way of living through conservation and modernization, to adopt climate-friendly and cleaner paths. And we have to use enhanced energy efficiency program, which we can get with the support of the industry, where Perform, Achieve, and Trade came in. And this is a program of Bureau of Energy Efficiency. My screen is actually restricting me from this. Yeah. Energy efficiency in industry. The AC Act empowers the central government to notify energy intensive industry identified as the designated consumer. And main are the thermal power station, fertilizer, cement, pulp and paper.
बलकार सर,
हाँ जी,
बलकार सर,
यस सर,
सर आपका स्क्रीन नहीं आ रहा, जरा दोबारा करिएगा.
ओके. Now, is it visible?
हाँ जी
Yes,
सर.
sir.
Okay. Okay. So I am talking about the designated consumers, which are consuming about 45% of the total commercial energy used in the country. And the designated consumers contribute to 25% of the nation's GDP. Economic growth and population increase adds immense pressure on these sectors to deliver. So thermal power will continue to be India's main source of electricity to decades to come. So Perform, Achieve, and Trade is the scheme initiated under the National Mission on Enhanced Energy Efficiency, and it has been notified on 30th March 2012. It is a market-based mechanism which is designed to accelerate energy saving in large energy-intensive industries, which are declared as designated consumers, by incentivizing the saving through energy saving certificates that could be traded. The industries who overachieve their targets will be issued e-certs, and the industries who underachieve their targets will levy penalty as per the Energy Conservation Act. So you can see that how you can calculate the specific energy consumption. Central portion process is the plant boundary, and the energy efficiency, energy is used from all forms, and this is the input, and the output is product. So energy used per product is the specific energy consumption. So you can see the band mechanism over here. On the left top, you can see that base specific energy of the industry, then target uh, given by the government, and achieved specific energy consumption. So you can see that they have achieved more, and they have been given as energy saving certificates. On the second portion on the right top, the base, they have actually achieved the target. Uh, they, 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 they have not achieved the target. Achievement is this, and they have to purchase the certificates. Then if the compiled is there, you can say the basic each SEC is given on the left side, and target is achieved by the industry. So there is no penalty, there is no issue of certificates. On the other hand, if an industry did not uh, achieve the target, then they have to purchase the energy saving certificate, either they have to give the penalty. So this is the PET mechanism. So stakeholders are: regulator is Ministry of Power, administrator is Bureau of Energy Efficiency, implementers are the designated consumer, which has been designated by the Government of India. Then implement, you can enforcement agency is state designated agency. Verifier is the empaneled accredited energy auditors. And the trading will be done through the traders, that is POSCO and CERC. So this is the these are the stakeholders. And now every designated consumers is required to appoint energy manager in his industry, in his unit, and his work is required to be checked by the energy auditors. So energy manager and energy auditors exam is being taken by the Bureau of Energy Efficiency every year. And this time, 20th certificate examination is scheduled to be held on 27 and 28th March 2021. If we see that in PET cycle 1, that was from 2012 to 2015, 3-year cycle. The target was 6.68 million ton of oil equivalent, and the industries are 478. And from this, the achievement is 8.67, that is more than 6.6. And energy saving 5,635 megawatt. The emission reduction is 31 million tons of carbon dioxide. And skill development is made for 5,000 engineers and operators, and 13,000 energy managers and energy auditors were certified. Saving is 9,500 crores, and investment is 26,100 crore in this PET cycle 1. In PET cycle 2, there is deepening and widening. Deepening means more industries were added, and widening is more sectors have been added. So in PET cycle 1, there was 478 industries, and in PET cycle 2, there is 621 designated consumers. If we see the PET cycle 1, there is 621 industries, and target was 8.869 from 2016 to 2019. And the achievement is more than that, from 8 to 13.28 metric ton of oil equivalent. And the emission reduction is 61 million tons of carbon dioxide. And capacity building is increased up to 12,000, and 17,000 energy auditors and energy managers have been certified, from which 500 has been accredited as energy auditor. And the saving is 31,445 crores. And the investment is 43,721 crores. So this is the realization of PET cycle 2. If we see the designated consumers list, so this is the sectors, and this is the threshold limit. And you can see that if the industry thermal power station, then 30,000 metric ton of oil equivalent is the threshold limit, from which are the industry more than that consumption is required to be designated as designated consumer. So fertilizer 30,000, cement 30,000, iron and steel 30,000, and you can see the textile is 3,000 only. And the pulp and paper again 30,000, petrochemical 90,000, electricity distribution system is also distribution companies has also been designated as designated consumers. Even railway workshops and railway zonal offices has also been taken as designated consumers. And one important is that the commercial building like hotels are also in the designated consumers. And this is the list of designated consumer in the state of Punjab. Inside PED cycle 1, there were 22. And PED cycle 2, 10 more added, 3, 4 more added, in 4, 2 more added, and in 6, 2 more added, and 40 industries are there in the state of Punjab under the Perform, Achieve and Trade scheme. And I would like to tell you that 1 kg of oil equivalent is equal to 10,000 kilocalories, and 1 metric ton of oil equivalent is equal to 10 is to the power 10 6 kilocalories. So this is the scenario of in the state of Punjab. And impact of PET cycle 1 in the state of Punjab has been that the 1,080 megawatt have been avoided capacity in the state of Punjab, and carbon dioxide emission reduction is 4 million tons of carbon dioxide, that is equivalent to planting 160,000 million green trees. And number of net positive energy saving certificates issued is 107,476. So industry is participating very well and achieving the energy efficiency. So for the educating, PSERC has also appointed an educating officer for the purpose of educating under Section 26 of the Energy Conservation Act 2001. So I would like to show a video, very interesting video, which gives you the overall view and how the industry is acting and how they are achieving the energy saving.
The industrial activities that our modern civilization depends upon have raised atmospheric carbon dioxide levels from 280 parts per million to 400 parts per million in the last 150 years, leading to global warming. Global warming, becoming the matter of worldwide concern, brought many countries to one table at 2015 United Nations Climate Change Conference. India, being one of those countries, submitted the target to reduce 33 to 35% emission of greenhouse gases by 2030. Taking complete responsibility to achieve the target, the government launched various missions like National Mission for Enhanced Energy Efficiency under National Action Plan on Climate Change, which consists of initiatives like PAD, Perform, Achieve, Trade. Many industries of aluminium, cement, textile, iron and steel, chlor-alkali sectors have been able to optimize their energy consumption in the PAT Cycle 1.
textile sector has a huge contribution in the economy. Under the PAD scheme, when it started in 2012, we included 90 units from different areas across the country, and they have overachieved their targets. That was for the PAD cycle 1.
The textile sector plays a major role by contributing to 10% of manufacturing production, 2% of India's GDP, and 13% of country's export earning. Shriram Rayon, being one of the major industries of the textile sector, has been owing the energy-intensive consumption pattern as it manufactures rayon's tire yarn and dipped fabric for high-speed vehicles.
With the B initiative of PAD cycle, we understood that we should go for boiler number 2 conversion in husk boiler, and this helped us to reduce further onward coal consumption by around 25,000 ton per annum. In 2010-11, we converted our boiler number 3. We reduced 30,000 ton coal consumption. Our specific consumption, which was 3.532 in base year 2009-10, is now reduced to 1.44 in 2016-17.
In steam bath section, we have replaced our filter bath pumps from old to new energy efficient pumps and achieved a saving of around 250 kilowatt.
Shriram Rayon has achieved specific energy consumption of 1.906 TOE per ton of product.
So our total vision and mission is, as of now, is what we can do, how we can do, and what are the steps we need to take as a management to reduce our energy. Our all 2,000 employees are well alert and they are there to save energy. And we have, based on our energy performance and energy savings, we have earned 14,550 e-certs, which is now being traded in the market.
We acknowledge Government of India, Ministry of Power, Bureau of Energy Efficiency for having such innovative PAD cycle, which helped us to have the formulation and give us the monitoring guidelines.
We have a future plan to reduce our energy consumption. One, we are replacing all our lights with the LED lights. We have already started working on i3 motors.
In the coming years, we are contemplating putting up a solar power plant of 1 megawatt, and it will not only reduce our power consumption but will also help in reduction in the carbon emission generated to the environment.
The industries have seen a tremendous success in energy savings, emission reduction, capacity building, savings and investments. Due to the training and success of the DCs under Bureau of Energy Efficiency, the PAD Cycle 1 also helped in market transformation for energy efficient equipment. With a vision of an energy efficient future, Bureau of Energy Efficiency is all set to take many more initiatives like PAD, Perform, Achieve and Trade, Energy Conservation Building Code, Star Rating of Appliances, Demand Side Management for a sustainable growth of the nation.
So when you have seen that how the energy conservation measures are being taken by the designated consumers, how they are achieving the targets, and they are very encouraged to save energy and save the environment. So I think I have completed within time. Thank you very much.
Thank you, Balkar sir, for explaining the PAD mechanism, which not only regulates but also aims to reduce the SEC in energy-intensive industries. And thank you for also explaining how these industries can actually trade in their specific energy consumptions and earn energy certificates for the same. I would request all the attendees to kindly fill in the feedback form that is now available in the chat section, and so that we could move forward. Let's move to our last session, I would like to call our next speaker to introduce us with the new design options to help us reduce HVAC energy consumption in a building. I would like to welcome Engineer AC Verma, who is a highly dedicated and experienced energy management and greenhouse certified professional. He is presently leading High-Tech Engineers Private Limited, an energy management and HVAC consulting firm. Over to you, sir. AC Verma, sir.
Thanks, madam. And a very good afternoon to everyone. Am I audible?
Yes, sir, you are audible.
Okay. Well, friends, after two very interesting and lucid presentation, it is my turn now to share a few dry facts about the new challenges in HVAC design concerning the health and wellness of the building occupants. But rest assured, I will not involve you in any mathematical intricacies during my presentation. So let me first share my screen with you. Yeah, my topic for the day is new design options to reduce building HVAC energy. During the COVID-19, we have all experienced that there have been regular instructions to increase the outdoor air supply to the air-conditioned spaces. And that exposed the inadequacies in our system design because our systems are primarily designed for the minimum outdoor air requirement. Even those few who could strain their AC plant's capability to the maximum feasible started getting the pinch of higher energy cost, increase in energy cost. But the COVID-19 taught us one very major lesson, that the individual, the personal health and happiness is now a top priority for everyone. So when people have started going back to their workplaces, these new challenges of providing higher quantity amount of outdoor air supply to the air-conditioned spaces and simultaneously reducing their energy bill is a big challenge. So here, this new concept is emerging, that is is resurfacing, rather I should say, because it will help us, the new concept of equivalent clean air approach, because it will help us not only to control the virus transmission within the air-conditioned space, but reduce our energy bill also. So this topic I will cover in the following sequence. The energy challenge in HVAC ventilation design. Then I will explain to you the concept of equivalent clean air and how to make it feasible. We shall discuss the alternate design options to the current practice of the ventilation rate procedure, that is the IAQP method and hybrid method, and a few examples of using the equivalent clean air approach with the IAQP procedure, where the energy saving has been achieved. And of course, I conclude. So the new challenges in HVAC ventilation design. We all know that HVAC consumes almost 50 to 60% of energy in a commercial building. And out of that, 25 to 30% is spent on the HVAC ventilation system. So what is the best solution to reduce this energy consumption? Of course, the best solution is natural ventilation. It is the most energy efficient solution. And when 20 years back, we used to see in places like Shillong, where the air conditioning system has a pre-cooling as its integral part. But natural ventilation has its limitations. It may not be feasible all the time, practicable all the time, due to site and architectural constraints, outdoor air pollutions, which is increasing day by day, and the temperature and humidity fluctuations outdoor. So the alternative is mechanical ventilation, which is a very integral part of the HVAC air conditioning system, our air conditioning system. So the new challenges in HVAC design are to enhance indoor air quality in air-conditioned spaces and simultaneously to reduce the increase in energy consumption due to higher outdoor air requirement. Presently, this ventilation system is designed on the basis of the minimum outdoor air requirement. That's why when the extraordinary circumstances demanded the extraordinary measures like higher and higher outdoor air supply, our systems were not able to match that. And that method, common method, is the ventilation rate procedure method, which has been laid down in the SRA standard 62.1. And this method is why it is very common, because it is a prescriptive design procedure. The amount of outdoor air has been specified, which is worked out on the basis of your space type and application, occupancy level, and floor area, and very simple formula, which is shown here, that is the design occupancy multiplied by the outdoor air flow rate per person, added by 2 net occupiable floor area and outdoor air flow rate per unit area, is the basis on which we work out the minimum outdoor air required. This is a two-part, because one is the requirement of the fresh air is for the breathing purpose, and that is the essential portion. So that is based on the per person. And then there are contaminant generation in the occupied area from the building interiors. So that is depending on that component of the minimum outdoor air is based on your unit area, floor area. So as we see, this is the minimum air required. We have worked out the minimum area required, but we have to now, after this COVID-19, the requirement of higher and higher outdoor air supply is required. And as we see, that has a challenge for the energy challenge. So this concept of equivalent clean air is very helpful, will be very helpful. And this one, if you see on the sketch on the right, you see this is your HU, where the outdoor air is coming, where the return air is coming. There is a filter, there is a cooling coil, and there is a air cleaning device is there. So presently, we are supplying the outdoor air. This was designed for the minimum outdoor air required, but we have to supply more and more outdoor air. The system does not match with that thing. So this concept, equivalent clean air approach, tells that if this outdoor air is replaced by the outdoor air equivalent, then the problem is solved. So this outdoor air equivalent is now have three components: the minimum air required, then filter efficiency based on the filtration, and then the air cleaning capacity of the HU. So these three components will now provide the same equivalent of same outdoor air which we require in the change scenario. So this equivalent clean air is the equivalency of actual outdoor air, which in combination with filtration and air cleaning technology will deliver the same ventilation outcome as provided by the higher quantity of outdoor airflow without fine filtration and air cleaning. And advantage is that it will reduce your viral load, this bacteria and virus within the space, because you are providing equivalent of higher quantity of outdoor air, and that will, but you are reducing your energy consumption. But it is not so simple as we feel, because if you add the three components, it may not be that it will serve your purpose, because you have not to consider it individually, but the whole thing as a system in a holistic way, so that you get the best effect. Now, even as the new guidelines which have come last month, considering all the new challenges, mentions talks about the equivalent clean air approach in all its recommendations. And if you just look at the recommendations, as the core recommendations for reducing airborne infectious aerosol exposure is based on equivalent clean air supply approach. It is a combination of the ventilation, filtration, and air cleaning, but that flexibility is there, how you achieve that. The objective is to reduce your viral exposure, and subject to constraints that may include comfort, energy use, and costs. These have not to be compromised. The comfort, energy use, and cost. So then you have to develop the best solutions. And there are few guidelines here: provide and maintain at least required minimum outdoor airflow rates. Minimum outdoor airflow rates, now it is based on the at least required minimum outdoor airflow rates. Then it talks about the combinations of filters and air cleaners to achieve MER with 13, that is the filtration effectiveness level, 13. Presently we have 6 or 8. Now it has to be increased to MER with 13 for a better level of performance. Yeah? And only use air cleaners for which evidence of effectiveness and safety is clear. Air cleaners, in short time, we shall not go into that much detail, but the air cleaners, every air cleaners has different effectiveness. And this effectiveness also depends on the kind of bacteria or virus which is present there. So we have to select the right air cleaners for the right applications, and the air cleaners should be safe in the sense there should not be any ozone generation. And objective is that select control options while minimizing associated energy penalties. So this guidelines also mentions that we have to minimize the energy consumption. So we have to improve the indoor air quality while reducing your energy consumption. And to achieve this clean air approach, there is one options available. There are options available. Yeah, this is the design options which can be explored. That is also mentioned in the ASHRAE guidelines. There is the indoor air quality procedure. This procedure and the earlier the VRP procedure, there is a difference. That is based on the prescriptive approach. That is, they have prescribed that, okay, if you do this, you are likely to get this result. But here, it is the performance-based design approach. Here, you design it based on the evidence available to you, and then you validate it through testing. So you can see in the flow diagram on the right side that there is a design aspects where you conduct a survey to find out what are the sources of contaminants, what are the type of contaminants, what are their emissions rate. Based on that, and how much is permissible, the concentration limits which is permissible, these are all given in the different guidelines which one can utilize. So you find out the concentration limits, and then you accordingly identify air cleaning solutions which are effective and which are efficient. There are a number of air cleaning technologies. Some are very old, some are the new emerging technologies. Some have their own advantage, their own limitations. So you have to identify the right air cleaning solution. And then with this combination, that further analysis is done, engineering analysis is done, that is known as the mass balance equation. It is that analysis is done, and accordingly the design is completed. But the challenge with this technology, this procedure, it was nothing new. It was already there, but the challenge was that this mass balance equation analysis was very cumbersome by doing it manually. But now with the softwares and coming in, these calculations and other things have become comparatively much easier. So this method can be, but it requires a lot of the ground realities. You have to understand the ground realities so that it can be right solutions can be developed. But this one is effective solution, and it is being used in different places abroad and in this thing and other countries also. So because after the design, you have the another portion component is the verification, where you have to test the result, whether this viral load has reduced or not, or your this different type of, because in a air conditioned space, not if there is only bacteria and virus, but there are number of other contaminants, and these contaminants also affect us. The virus may be a killer virus, but the other contaminants may be the slow poison. So these have to be all attacked. And during this COVID, we have come to understood that these killer viruses, people with comorbidities are more susceptible to this killer virus. So the indoor air has to be considered not only for the bacteria and virus, but for other contaminants also. So then it is the verification is done, validity is done. That validated is also done in two parts. It is one is the physical testing. It is the laboratory testing, physical testing of the indoor air quality, and then there is a that there is a survey. There is you can say that is your subjective evaluation. That is a subjective evaluation. One is the objective evaluation of the contaminant concentration, and one is the subjective evaluation where which perceived the result which have achieved, the cleanliness, the hygiene which we have achieved in the workplaces, that has to how the occupants perceive it, that is done through the survey. So this way is very effective to control improve the indoor air quality, and that's why this name is indoor air quality procedure. It is also another alternative to the VRP method. And these two, if they combine these two, then you can have a hybrid method, because with the ASRE method, this IAQP method, the minimum indoor air quality is lesser than when this your VRP method, earlier method. It is a present method. This is also lesser than that. So one can think of that, okay, I have designed it as per the VRP method, so I at least get some more air, outdoor air. There is feasibility of getting more outdoor air, but I am operating my plant based on the IAQP method, because ultimately my contamination control is being achieved. So the focus is now will be shifting from the increasing the outdoor air quality to achieving the contamination control in the air conditioned spaces. And this is one of the very important example I am just showing you, that is the IAQP method. And you can say also the hybrid method, because this is the Duke Energy Center in the North Carolina, USA. And this is a LEED Platinum certified building, 240-meter tall, having 54 floors. And yeah, since it is a platinum rated building, people talk about your solar panels on the walls, the water efficient fixtures, the other things they talk about but very few people talk about the HVAC ventilation system, which it works in the background. So when this project was being designed, the client had two requirements. He said this building is to be designed as a LEED certified building, platinum building. Second thing, he said that you apply this IAQP method to reduce the energy cost. They insisted that the energy cost had to be reduced by the IAQP method. Now the challenge was that LEED version at that time, this building was in 2010 or 2008, it was being designed at that time, 15 years back. So the challenge was that how to get it, because the LEED version at that time had the provision that only VRP method can be used, though ASRE allows for the IAQP method, but the LEED did not allow at that time. So the consultants, and the client insisted that you have to get the LEED certification also, and the IAQP had to. The consultants found a way. They said, okay, let us design it based on the minimum air requirement based on the VRP method. And they also designed it based on the IAQP method. So VRP method helped them to get the LEED Platinum certification, and IAQP method helped them to reduce their energy cost. So this hybrid method they used, and they have been very successfully, this building has been operating for a long time, because it is one of the headquarters of the Duke Energy Center is located there. And a few other examples I will just give. My colleague has been doing these projects and in the USA, and we have done a project in India. We are doing this project. So in middle school, in Indiana school building having 1 lakh square feet, they applied the IAQP method, because the children are very prone to infections from the indoor air, bacteria, virus, and contaminants. So schools are going for to improve their indoor air quality. At the same time, they want to reduce their energy bills. So they applied this concept there, and they have been able to save to be $24,000 per year with a payback period of 30 days. In a similar school, having 1,20,000 square feet of area, they applied it and they are getting a saving of $30,000 and payback of 24 months. Because the payback will depend on the type of problem is there. And another airport, the project, they are getting an annual energy saving of $35,000 and payback of less than 2 months. 2 months. Similarly, for a sports center, they are getting the annual energy saving. They applied it in the hotel. We have applied it in an auditorium building at a design stage, and the design value which we were getting when we compared with the two procedure, the VRP procedure and the IAQ procedure, we find that the outdoor air reduction of 31% is feasible, which reduced my cooling load to 23%. And only we take the energy saving is 3 lakh rupees, 3 to 3.5 lakh rupees annual saving will be there. And since their cooling load reduction is there, the capital cost of the project will also reduce, the AC plant will also reduce, and it will give a payback period of 15 months. So from these examples, we find that the incremental cost of healthy indoor air quality is zero. If the right solutions is applied, the incremental cost of healthy indoor air quality will be zero, energy will be zero. And if we take the productivity gain from this improved indoor air quality, the return will be at least four times more than what we are showing in the annual energy saving. As I said, there are a number of technologies, and in short time we cannot discuss all the technologies. Every technology has its merits and certain limitations, and we use depending on the applications, we select the technology accordingly. But one technology I just wanted to mention to make you familiar, that is a very promising air purification technology, which is a very suitably can be used in the IAQP method. That is the NPBI technology. It is a needle point bipolar ionization technologies, where the ions are generated, positive and negative ions are generated, and these ions travel with the outdoor air flow, the recirculated air, and that cleans the air within the ducts and also within the space. And it has been very effectively used, is used in different places, because if you see the benefits, it kills virus and molds, spores, and bacteria up to 99.9%. It depends on the type of bacteria, virus. It removes odors, VOCs, and fine dust particles, reduces outdoor air demand, saving energy up to 30%, clean, biosafe, and healthy facilities for occupants, and prevention from indoor air acquired infections. So, and the other advantage is that this is the maintenance-free, self-cleaning type, no replacement parts required, no ozone generation, no pressure drop, energy saving is there, low voltage supply. So what I'm saying is now the new technologies after the COVID has become very being widely used, the promising technologies. So when we select the technologies, we have to see which technology is appropriate for our solution. To conclude, I will say that equivalent clean air approach is now going to be more and more widely used, because it will reduce the need for a higher outdoor air, and this indoor air quality procedure and air cleaning will help it to reduce energy cost reduction and safe indoor air. And this together will make our HVAC design energy efficient and resilient to meet the future challenges. Friends, one thing that we must remember, that this deadly virus does not make any difference between the rich or poor, low or high or low. But it has a preference for the people staying in air-conditioned spaces rather than in the non-air-conditioned spaces. So we as facility managers, we as building professionals must consider this indoor air quality, the health and wellness of the building occupants a priority in our design and operations. Thank you so much. Thank you very much.
Thank
If
you,
you have
sir.
any questions,
Sir, there are two questions for you, I think so. They are directed towards you.
Yeah.
One is by Mr. Sanjeev Bansal. What should be the outdoor air flow per person?
Per person. That is the outdoor air flow person. It as per if you go to the ASHRAE code, it varies for the different type of occupancy. It varies. But normally, if you take the minimum is the 5 CFM per person is required for breathing, for the freshness in your breathing air. But for some school spaces, another, it may be 10 CFM. So these are given in the guidelines there. So we have to refer there because we follow the ASHRAE or this one or NBC, National Building Code. It is also mentioned in the building code. So from there we can take it in our design. But minimum is 5 CFM.
Before moving to the next question, I would request all the attendees to kindly fill in the feedback form available in the chat section, and also kindly raise your questions if there is any. Verma sir, there is another question which is directed to you. That is, which method is better? Is it IAQP or hybrid method?
As I said, this hybrid method is is a combination of the PRP method and IAQP method, because it is you say it is for convenience. Many times people with the IAQP method, people have certain reservations whether it means to that what result will come. So as I said, in the Duke Energy Center, they designed it for the VRP method. They designed it for the IAQP method also. So in the IAQP method, the energy outdoor air requirement was lesser than the VRP method. As I said, the 5 CFM is the minimum required for the breathing purpose. Freshness in our breathing air for the breathing purpose. So the amount of outdoor air is lesser in the indoor air quality procedure and than this thing. But this one has to be, as I said, it is a performance based. So more technicalities are involved with this one. The BRP is a prescriptive based. It is just you see the guidelines, the table, and just calculate. But of course, the IAQ will be more and more popular in the future, because the COVID has changed the complete your rules of the game.
There is another question. Sir, either you or I think so Akshay sir can answer this. How air quality can be improved in an existing building?
I will just give, then I think Mr. Akshay can also add testing. I will can the existing building. Actually, this is that's why I mentioned there are certain technologies which will help you to, as I mentioned one technology. I'm not promoting any technology, but in that way. But I mentioned the NPBI technology. This has almost a zero pressure drop. In one recent case, in a dental center, because many of my friends are from the hospital. So in a dental center, the existing dental center, they wanted to improve their indoor air quality. This thing. And one of the vendors, they just gave their recommendation. They said make it the HEPA filter, provide the HEPA filter with the UV tubes. And the limitation was that when we were involved in this project, when we were asked to involve in this project, when we found that the HEPA filter is not suitable there because the existing HU has its own constraints. The pressure drop was much more there. So that's why I'm saying there are technologies, right technologies are there. You have to select appropriate technologies, and the existing system can be made your biosafe and energy efficient. It is possible, it is feasible. Because in the short time, I will not go into that, but if you want to discuss it further, my number is there, we can always talk. And if Mr. Akshay want to add to this thing, he can.
Thank you, sir. Thank you, sir, for your session. It has been very informative. HVAC surely is the most energy consuming part of the building that works in the background, that impacts the indoor air quality, as you mentioned. And actually mentioning as the IAQP and BRP methods importance and emphasizing it, how they can actually help us build a healthy indoor air quality. Thank you so much, sir. I think so. There are no more questions. And if there are questions, you can mail us the questions. The link for the feedback form is in the chat box, and the YouTube link for today's session is also there. Moving forward, now I would like to invite Architect Guneet Khurana from Amritsar to conclude the sessions. Over to you, sir.
Thank you. Thank you, Mansiji. Good evening, everyone. My name is Architect Guneet Khurana. I have listened to all the expert talks. Mr. Akshay Gupta has very rightly advocated that Indian architects should design buildings to suit local climatic conditions rather than copying Western ideas blindly. He stated few examples very aptly as to how we can reduce the carbon footprint and how we can save money and energy by using energy efficient materials and techniques. He was quoting a few of the examples as well by stating few of the he told about how he and his colleagues saved crores of money by designing the buildings accordingly. Engineer Balkar's topic was very relevant as well. He highlighted on the importance of using PAD, which is the performance, achieve, and trade in industries to conserve energy. Engineer AC Verma spoke on ideas to save energy in air conditioning specifically. We all know nearly 50% of energy consumption in buildings is related to air conditioning alone. He shared his vision to save electricity for doing air conditioning in projects. The message of all the speakers is very crystal clear as to we all should save energy, save environment, and save Mother Earth. Thank you.
Thank you so much, Guneet sir, for mentioning actually save Mother Earth. That is what the need for the art is. Now, without taking much time, I would like to invite Architect Ramneet Gharyal to give vote of thanks to all our attendees and actually conclude the session. Over to you, ma'am. Ramneet, ma'am.
Thank you. So good evening, everybody. It is my immense pleasure to propose a vote of thanks for the contribution of each and everyone for having made this webinar a memorable event. We would like to express our deep gratitude to Punjab Energy Development Agency and BEE for giving us this opportunity to meet and exchange knowledge. We would like to convey our thanks to Architect Anmol Pupneja for his welcome note and Dr. Aradhana Jindal, Principal MM School of Architecture, Ambala, for her introductory address. We are thankful for expert speakers, Architect Akshay Gupta, Engineer Balkar Singh, and Engineer AC Verma. Special thanks to all the officials from PEDA for their valuable support. We are grateful to the officers and staff of industries, designated consumers, energy auditors, managers, energy service companies, ESCOs, etc., owners, facility in charges of hotels and hospitals for attending this program, and Sakar Foundation Chandigarh for ably conducting this program. We are grateful to the office bearers of IIA Punjab chapter and Chandigarh chapters for supporting this program. Our special thanks are due to all of you for spending your valuable time for our sake. Thank you very much indeed, all of you. And last, I would like to thank Ms. Mansi Ghavri for her wonderful comparing of the webinar. And our deep gratitude is due to all the media personalities for their wholehearted support of this program. Thank you very much.
Thank you, Ramneek ma'am. In the end, I would like to thank all the attendees, and would like to remind you to kindly fill the feedback forms. Link is available in the chat box to all of you. Hope you all have a remarkable day ahead. I also request you all to join us in our coming sessions, which are due tomorrow and day after. Please join us and help us make this webinars and this celebration of Energy Conservation Week with PEDA a success. Thank you all. Have a good day.